Right now we are doing problem number 8 for Engineering Calc from the Spring 2011 Exam 1. So number 8 asks us which correctly describes the discontinuities of the function f of x below. And so they give us this function f of x, and it's going to be a piecewise function. So f of x is equal to 1 when x is less than 1. Our function is equal to 2 square root of x minus x when x is between 1 and 4. And then our function is equal to ln of x minus 3 when x is greater than 4. Okay, so we want to figure out all the different discontinuities of this, and so first we're going to have to see if the function exists everywhere, and then we're also going to have to figure out what's happening at 1 and then again at 4, because that's where our function's changing. Okay, and so when we're figuring out if a function exists somewhere, if it doesn't exist, what we want to look at is square roots and ln's for this problem, because we know square root, whatever you're taking the square root of, it can't be negative. And in our case, it's the square root of x only when x is between 1 and 4. So this is never going to be negative, so that part's okay. And then we're going to go down and look at the ln. And we know we have to take the ln of something that's greater than 0. And so we're taking the ln of x minus 3 when x is greater than 4. So we know that this is always going to be greater than 0 as well, because we're only plugging in x values that are larger than 4. Okay, so we know everything's good so far. So what we need to figure out is what's happening at x equals 1 and then at x equals 4, because that's where our discontinuities are going to be. So what we want to do is we want to do the limit as x approaches 1 from the left of f of x, and then the limit as x approaches 1 from the right of f of x, and see if they match up. And then also we want to see what f of 1 is actually equal to. Okay, so the limit as x approaches 1 from the left. So if we're approaching 1 from the left, then we're going to use the function value where x is less than 1. So we're going to be using this right here. So we're doing the limit as x approaches 1 from the left of 1, which is just going to be equal to 1. Okay, because the limit of a constant is just the constant. And so now for this, the limit as x approaches 1 from the right. So if we're approaching 1 from the right, then it's going to be values that are greater than 1. So it's going to be this one right here. So it's going to be the limit as x approaches 1 from the right of 2 square root of x minus x, which if we plug in 1, it's just going to be 2 times 1 minus 1, which is 1. Okay. So our limits from the left and our limit from the right, they're both approaching 1. So they're approaching the same thing, which means the limit exists. However, if we actually figure out what the function is equal to at 1, so let's go back and look at our function. So the function is equal to 1 when x is less than 1, and it's equal to this when x is greater than 1. However, neither of these are less than or equal to or greater than or equal to. So we don't actually know what the function is equal to at 1. The function is undefined at 1. They don't tell us what it's equal to. So f of 1, we don't know what f of 1 is equal to. We don't know if it's equal to 1. So even though from the left and the right it's both approaching 1, there's a hole at 1. So there's a discontinuity at 1, and it's a hole. Okay, and so now we need to figure out what's happening at 4. So again, we're going to do the limit as x approaches 4 from the left and 4 from the right, and then what f of 4 is equal to. So if we're doing the limit as x approaches 4 from the left, so we need to do values of 4 that are values that are less than 4, because we're coming in from the left. So that's going to be this function right here. So it's the limit as x approaches 4 from the left of 2 square root of x minus x, which is going to be equal to 0. And then we're also going to do the limit as x approaches 4 from the right, which, because we're coming in from the right, so it's values that are greater than 4, so it's going to be this one right here. And so it's the limit of ln of x minus 3, which is also going to be equal to 0. Okay, and so the limit from the left and from the right is equal to 0. And so we know the limit exists. However, we have to figure out what's happening at f of 4. And so let's go back and look at our inequalities. So this one is when x is greater than 4, but not greater than or equal to. This one is when x is less than or equal to 4. Okay, so we're going to be using this one. So f of 4 is equal to 0. So the function exists and the limits exist as well, so there's no discontinuity of 4. So we only have a hole at 1. So there's one hole, no other discontinuities, so our answer for this one is B. And that's it for number 8.